last lesson, we learned how do you determine if a sequence converges or diverges. And in 8.2, from 8.2, we are going to start how do you prove a series converges or diverges. So today we are going to go over the definition of convergence for series and also telescoping and geometric series. Next lesson, we are going to learn nth term test for divergence. So what's the definition of the convergence for a series? So first, what is a series? A series is the sum of the terms of an infinite sequences of numbers. So infinite series a1 plus a2 plus dot 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 an. The nth partial sum S of n is given by the sum of the first n terms. For example, S of 1 is the sum of the first term, which is a1. S of 3 will be a1 plus a2 plus a3. S of 5 will be a1 plus a2 until a5. So this is what we call the partial sum. So the series, keep in mind, is the sum of the terms. Let's look at the definition of the convergent and divergent of series. So for infinite series, a of n, sigma notation n equals 1 to infinity a of n. The nth partial sum is the sum of the first n numbers. If the sequence of the partial sum, so if we put all the partial sums S1, S2, S3, S of n all together, this will give us a sequence. If the sequence of the partial sum S of n converges to a number, then we call the series will converge. And if the limit S, it will be called the sum of the series. And S will be the sigma notation, the sum of the whole series. If S of n diverges, then the series will diverge. So that means you have to evaluate S of n as a function of n. And if you can prove S of n as n go to infinity goes to a number, then the series will converge. However, it's not always that easy to find S of n. That's why in this chapter, we are going to learn some different type of methods to prove the convergence or divergence of a series without calculate the sum of the whole series. Let's have a look at this example. How do we determine if the series given here converges or diverges? If you look at the an here, an equals 1, that means the sequence will be 1, 1, 1, all ones. So S of n will be 1 plus 1 plus, you have n ones, so S of n equals n. As limit n go to infinity, S of n will be infinity. So this tells us the series diverges. However, if you look at an, as n go to infinity, a of n equals 1, which is a number. So the sequence does converge. So even the sequence converges doesn't guarantee the series will converge. This is a very good example. So in this lesson, today we are going to learn two types of series. First type, telescoping series. Telescoping series is some type of problem. You can cancel a lot of middle terms. Let's have a look at this one. So if we write n equals 1, we plug n equals 1 in. This will give us 1 minus 1 half. And when we plug n equals 2 in, we'll have 1 over 2 minus 1 over 3. N equals 3 in, 1 over 3 plus 1 over 4 minus 1 over 4. And keep going, it's 1 over n minus 1 over n plus 1. So as you can see, the 1 half, 1 over 3, and everything is cancelled. And the last term left will be 1 minus 1 over n plus 1. So basically, this is the nth partial sum. And then we look at the limit as n go to infinity, 1 minus 1 over n plus 1. As n go to infinity, this gives us 1. Because the sum goes to 1, so the series will converge. Similarly, if you have some problem like this, when you see a fraction like this, we can use partial fraction to write this as a over n plus b over n plus 1. Now a4 equals a times n plus 1 plus b times n. We just solve for ab. We plug n equals 0. We get a equals 4 and n equals -1. That gives us b equals -4. So the sigma will be n goes to 2 to infinity 4 over n minus 4 over n plus 1. So we start with n equals 2. We plug n equals 2 in. So this will give us 2 minus 4 over 3. n equals 3. 4 over 3 minus 4 over 4. Plus da da da. And you can see a lot of terms will be cancelled. Okay, cancel, cancel, cancel. The final answer will be 2 minus 4 over n plus 1. So as n goes to infinity, 2 minus 4 over n plus 1 goes to a number 2. So the series converge. For telescoping this type of series, you just need to write each term and find the pattern and solve the limit. The next type of problem will be geometric series. For geometric series, the most important concept here, which we call the common ratio, R. So given a times r, a times r squared, a times r cubed, the common ratio is r, this type of series which we call the geometric series. For geometric series, if the common ratio is between -1 and +1, we can directly claim the series converge and will converges to a1 over 1 minus r, where a1 is our first term. Otherwise, the series diverges. So if you can claim the series is a geometric series, then it will be so much easier to solve the limit and to identify if the series will converge and also where the series will converge to. This is the sum. Let's have a look at example 1. Given sigma n equals 0 to infinity, so sometimes it's not easy to identify this geometric series or not. You can list some terms. N equals 0, which is 3. N equals 1, 3 over 2. N equals 2, 3 over 4. So from here, we can tell R equals 1 over 2. So which is A2 divided by A1, right? A2 over A1. So this common ratio, R is between -1 to 1. We can directly claim the series will converge. Series converges to A1, which is 3 over 1 minus R, 1 over 2, give us 6. Okay, everybody, you can try number 2 and number 3 yourself and compare your answers with mine. Okay, these are the answers for number 2 and number 3. Have a look and let me know if you have any questions. So given the properties of the infinite series, given sigma an and bn, both of them converges to a and b, and c is a real number. In this case, if we multiply an by constant, the sum will be c times a. The sum and difference of the two series will be a plus b and a minus b. And homework will be posted on the class calendar.